In this video, we will learn about geostationary satellites. A geostationary satellite is in orbit above the equator and it never appears to move when viewed from any point on the Earth. Now, what does this mean? I have drawn a diagram here. If it's a geostationary satellite, it will be facing the same part of the Earth. For example, if there was a geostationary satellite right above India or Sri Lanka, then that satellite will always be above that country. So that means it will have a period of 24 hours. You know, the Earth takes 24 hours to make one rotation. 24 hours is 1 day. So Earth takes 1 day to complete one rotation. Now, for this to be above the same part of the Earth, that means it should also have a period of orbit of 24 hours so that it can face the same part of the Earth. So when the Earth rotates, in order for the geostationary satellite to face the same part of the Earth, it should have a period of orbit of 24 hours. What do we mean by period of orbit? That it takes 24 hours to complete one orbit around the Earth. And geostationary satellites, from the name itself, you can understand geostationary. That means if you see it from the Earth, it looks stationary because as the Earth rotates, it also orbits the Earth. So it appears from the Earth as if the satellite is not moving. For example, let's say you are in a car. I can sketch a diagram here. Let's say you are traveling in a vehicle. Let's say this is a car, and right next to this car there is another car. So this is a road. There is a road like that, and then let's say this is another lane of the road, and there is another car like this. Okay, so what happens? This car is moving that way at, let's say, 50 meters per second, and this car is also moving in the same direction at 50 meters per second. So if you are inside this car, or even somebody inside this car, when they look at the other vehicle, they will see as if that vehicle is not moving, because both are moving at the same time with the same speed. They are moving together like this. So it appears as if it is not moving. So that is something that is happening here. So from the name itself, geostationary, you can try to understand from the name itself what this means. Then these geostationary satellites have a constant distance from the surface of the Earth, which is about 36,000 kilometers from the surface of the Earth, and from the center of the Earth it's about 42,300 kilometers. So remember, from the surface it's 36,000 kilometers. From the center, if you add the radius of the Earth to this, then it will be about 42,300 kilometers. These geostationary satellites, since they are supposed to be at this fixed distance from the surface of the Earth, they are located in the Clark belt. There are about 300 geostationary satellites orbiting the Earth, which are all in the Clark belt. The Clark belt, the circular orbit of the geostationary satellite. So this, what I have drawn here in brown, is the Clark belt, which is the orbit of the geostationary satellite, and this orbit is a circular orbit. Geostationary satellites are parked in the Clark belt high above the equator. And remember, the geostationary satellites are above the equator. We will see that here. This is a perspective view. The Clark belt is circular. They orbit the Earth in the same direction as the Earth rotates. Earth rotates anticlockwise. If you look from the top down, Earth rotates anticlockwise. Then this orbits also anticlockwise. It orbits the Earth anticlockwise if you look from the North Pole down. They orbit the Earth in the same direction as the Earth rotates at a height of 36,000 kilometers above the Earth's surface. At this height, each satellite has a period of rotation of 24 hours. I already explained that. This means that each satellite naturally takes 1 day to orbit the Earth, exactly the time that it takes a point on the surface of the Earth to make one complete rotation. Now you can imagine that there is a pole fixing the Earth to the satellite. So imagine there is a pillar that is fixed to the Earth and also fixed to the satellite. And what happens when the earth rotates? This satellite also moves with that. So it's something like that. If you imagine there's an imaginary pole or pillar connecting the earth to the satellite, then when the earth rotates, this thing also moves. So it's something like that, but without the pole. As the earth rotates, this also orbits the earth. Geostationary satellites used for communication can transmit to each other around the world, but they cannot always receive from regions close to the poles, as the curvature of the earth blocks the signal. Now, if you consider the poles, see, this is curved, right? So that signal can't come all the way around to this side. Even from here, if you look, if it is on the other side, let's say 180 degrees on this side, then the signal has difficulty going to this satellite. But there are other geostationary satellites on this side. Since all these geostationary satellites are above the equator, parked on the clock belt, the signals from the North Pole or the South Pole can't really reach those geostationary satellites. So we can't really use cell phones, for example, when we are at the poles, if they are to transmit those signals to these geostationary satellites directly. See, they cannot always receive from regions close to the poles, as the curvature of the earth blocks the signal. The features of a geostationary satellite. So quickly we can see what we learned here. The satellite rotates with the same period as the earth. The satellite is in orbit above the equator. So here again, very important, the satellite is in orbit above the equator. So these are all above the equator, parked in the clock belt. And we have a period of 1 day or 24 hours. The satellite appears to remain fixed in position above a point on the equator, and so satellite dishes do not need to be moved. If you look at let's say a scheme of houses, or if you go to your rooftop and look down, maybe you might see the houses all have the satellite dishes facing one direction. They are all facing that geostationary satellite, you can imagine. Okay, so all this was in the theory lesson. Then finally, some uses. They are used for telecommunications, transmitting telephone messages around the world, and for satellite television transmission. Now, this is one type of satellite. The satellites which are parked in the clock belt or geostationary satellites, they always face the same part of the earth. There are about 300 geostationary satellites, and they have a period of 24 hours. Then we also have the polar orbit satellite, which is orbiting the earth in the vertical plane like this. Now this is in the horizontal plane. The polar orbit satellites orbit the earth like that. From the North Pole to the South Pole, they have a period of about 100 minutes. So when the earth rotates in 24 hours, they orbit the earth several times. And those satellites are used for example, to observe the surface of the earth, maybe for military purposes, then for weather forecasting. Those types of satellites are used, but these satellites, geostationary satellites, are used for this purpose. Okay, so that's the end of that.